Friends, today we are going to discuss how to calculate the power consumed by centrifugal compressor and other parameters related to centrifugal compressor. If you see the formula mentioned in the slides, that is the work done using temperature rise by thermodynamic method, that is work done W is equal to Cp T2 minus T1, where T1 and T2 are the inlet and outlet temperatures. Cp is the specific heat at constant pressure. So if you take T1 common, then Cp T1, T2 minus T1 minus 1, and we know that P2, Pv to the power gamma is equal to constant for polytropic process. So Cp T1 equal to P2 by P1 to the power k minus 1 by k minus 1. So K is the specific heat ratio and N is the polytropic index. So this is the formula used for calculating the work done by a centrifugal compressor. Now this is the polytropic, how to calculate the polytropic heat of polytropic heat. Now this is the H polytropic heat, that is ZRT1 by N1 minus N by N, P2 by P1, N1 minus 1 by N index minus 1. And similarly for adiabatic heat, in place of polytropic index N, it will be specific heat ratio, and the work done is equal to brake horsepower is equal to, that is called W. W is the flow, W is the flow per minute, and pounds per minute, and then polytropic heat divided by EP by 33000, and for adiabatic it is the flow and adiabatic heat by adiabatic efficiency, that is the brake horsepower adiabatic divided by 333. The compressibility here, Z is the compressibility factor, molecular weight is equal to MW, gas constant R is equal to gas constant per molecular weight, temperature degree Reynolds, pressure P1 P2 all are in absolute, K is equal to specific heat ratio, flow is equal to W pound per minute, and EP and EA are the polytropic and isentropic efficiency. And how this factor 33000 has come? Now we know the 1 HP is equal to 550 foot-pound per second. If you convert it into minutes, because here telling that flow are in minute, pound per minute, so we have to multiply by 60, that is equal to how much? Now 33000. That's why the factor 33000 has come. Now the relationship between the isentropic heat and isentropic heat between specific heat heat ratio and specific heat K and polytropic index N. N minus 1 by N is equal to K minus 1 by K into 1 by K e to the power P. E to the P is equal to polytropic efficiency. K is the specific heat ratio. This is the relationships between these two. Now if you use efficiency, if you the isentropic efficiency, isentropic EA, isentropic efficiency P2 by P1, K1 minus K by P, N1 minus N by 1 minus 1 minus 1, and N1 minus 1 by N is equal to, that previously we have seen it, N minus, this is the N1 N is equal to K1 minus N by K into 1 by it K e to the power P. So here we just simply convert it. So adiabatic efficiency and the relationship between adiabatic efficiency and polytropic efficiency is like this. So these are the relationship between isentropic and adiabatic or polytropic efficiency. Now polytropic and adiabatic process. Which one is called polytropic process, adiabatic process? Now, practically it is impossible to have a perfect adiabatic compression, which by theoretical definition of adiabatic means during the compression process no heat enters or leaves the system, when the system is represented as a perfectly insulated box from its surrounding. If your compressor is perfectly insulated, so no heat will go out and no heat will come inside. But polytropic compression process, a small amount of changes can take place, heat can absorb and heat can removed during the entire compression process. So the performance and efficiency of a centrifugal compressor can be defined in terms of adiabatic compression process, but polytropic compression process provide more realistic performance of the centrifugal compressor compared to an adiabatic compression process. Because adiabatic compressor, ideal adiabatic compression is not possible because some heat will go out and some heat will go in. So polytropic process where normally is useful. So we are giving you some example. You see, the calculate the centrifugal compressor power. How to calculate? Then properties Z, the compressibility factor, molecular weight MWO, inlet gas temperature, inlet gas pressure, outlet gas pressure, adiabatic compression, adiabatic component, K CP by CV, specific heat ratio, mass flow rate, etc. Everything is given in US unit. So compressibility factor they have given 0.9972, molecular weight also given 18.15, gas constant also they have given, T1 temperature they given, P1 pressure is given, P2 outlet pressure is also given, K specific heat ratio is also given, flow is also given pound per minute. The required data to calculate the centrifugal compressor power, that is compressor power. So either we have to measure the heat, and we can use either adiabatic heat or polytropic heat, as long as we use adiabatic efficiency and polytropic efficiency in companion. So if we polytropic heat, this one is the polytropic heat. You see, this one is the polytropic heat. This one is the polytropic heat. This one is the adiabatic heat. So and this is the flow and polytropic heat. That is the polytropic brake horsepower. This is the adiabatic brake horsepower. The adiabatic brake horsepower. So if you know all these things, so by using the equation, that previous equation, we get polytropic heat is equal to at a foot pound per foot pound force by per minute, and power requirement is equal to at HP, and get polytropic efficiency is 73.99 is the efficiency. So if you put all this figure in the above, you will get the polytropic heat, then polytropic heat, and then polytropic and power requirement also you will get, and polytropic efficiency also you will get. So also we will get by using the above formula. So I think I have covered the very important topics, that is how to calculate the power from centrifugal compressor, and actual power you will get from the how much taking it is taking that motor, from the motor also we can get how much power it is giving to the compressor, and polytropic output from the output work done also from the compressor, so you can get come down what is the polytropic efficiency also. So I think if you go through all these parameters, all the slides, your concept about polytropic efficiency, adiabatic efficiency, polytropic heat, adiabatic heat, work done will be clear. So if you still have any doubt, you can mail me. I will reply you. Thank you very much.